So share screen, share screen. Now we're live. All right, say hi, everyone. Okay, here we go. Here we go. So first we're looking at question number 1. Question number 1 says find sine R. R is my theta, or the angle I'm talking about. So because of that, I know my opposite is going to be, here's my hypotenuse, if this is my angle R. This is my opposite. This is my adjacent. So for here, sine R, well, we know that sine is opposite over hypotenuse. So my sine is 40. My hypotenuse is 58. So all I need to do is reduce the fraction. There's 2 ways I can reduce the fraction. One is I can just divide the numerator and denominator by 2 and get 20 over 29, which is the correct answer. The other way that you can do it is kind of a hack, is if you just type in 40 divided by 58, we get a decimal of 0.689. So what you could do is you could type in each one of those fractions as decimals. So if you stink at reducing fractions, you can just type it into the calculator, get the decimal equivalent, and then that way you know what your answer is going to be. And you can just compare the decimals. So either way that you do it is fine. Cosine R we know is adjacent over hypotenuse. So I've got 42 over 58. I'm going to show you the hack again. So in my calculator, all I'm typing in is 42 divided by 58. My decimal is 0.72. So that means I know it's going to match up with choice A. My tangent for R is opposite 40 over adjacent, which is 42. This one I'll reduce the fraction. That's 20 over 21. So choice D. I don't know why they had bad as the first, but that's what they did. Now we have sine S. So I'm going to change, because we're changing the angle. The issue is that this is no longer adjacent. This is opposite. And this opposite is now adjacent. So I've got sine S. Sine is opposite over hypotenuse. So 42 over 58. If you don't feel like reducing, oh, we already have that. 42 divided by 58 is 0.72, so we know this is A. Cos S, here's S. Cosine is adjacent hypotenuse, so 40 over 58. If you don't feel like reducing, we know it's 0.68. Now, I know some of you like to use your calculators. However, the only thing is that on the fraction, you won't have a fraction button when you take the EOC. So tan S is 42 over 40. So that's why it's good to come up with other strategies. So this is choice C. Down here, it says matching sine A. Well, here's A. A is our theta, the angle we're talking about. We always find our right angle, label the hypotenuse. Remember, with hypotenuse, angle, adjacent. Here's my opposite. Sine A, well, sine is opposite over hypotenuse, so that's 15 divided by 17. So we just take our calculator, 15 divided by 17, and we get 0.88. So this will be choice B. Cosine is adjacent over hypotenuse, so that's 8 divided by 17. Calculator, 8 divided by 17, 0.47. And then tangent is opposite over adjacent, 15 divided by 8, 15 divided by 8. Choice A. In the figure below, the triangles are similar. So we want to know what tan X is. Remember, similarity means the angle measures are the same and the sides are proportional. So the easiest way to do it is to look, well, angle X measures up with angle A, because A is my first letter in this triangle, so X has to match up with it. So A is now going to be my theta. And it wants to know tan, so I'm going to label it. Here's my right angle, so this is my hypotenuse. Hypotenuse, angle, adjacent, opposite. Tan is opposite over adjacent. So I know that tan of theta, or tan x, equals my opposite, 32, over my adjacent, 28. And you could leave it, you can't really leave it like that. You'd have to really reduce the fraction, so you should get 8 over 7. Or you could have done 32 divided by 28 and gotten 1.14. You didn't have to find the angle measure here because it didn't ask you to. It asks you to find what's the ratio, what's the number. Down here, our main thing here is to make sure that you have sine and cos on each side. That's the whole idea with complementary. So if this is sine, I need to make sure that I have a cos. So if that side says sine, this is going to be cos. If this says cos, then I know I have to have cos as my solution. Okay, because they're buddies. If you ever see sine, you see cos. So now, so it's always going to be cosine. We don't have it yet. The next thing you need to do is you need to find the complementary part. So 90 minus 38 on the calculator, I think, is 52. So this is going to be 52 degrees. Here's our cos, 90 minus 50. This is going to be 40. Here we have 32. 90 minus 32 gives you 58. So this is 58. So it's going to be choice C. So basically it says, now it says if cos theta equals sine beta, which of the following must be true? Well, we know that if we add these up, these always have to equal 90. So we know it's going to be choice E because their sum is always 90 degrees. So we know it cannot be choice D. And we know we're not subtracting to get 90, so it can't be choice A. We know that these are complementary angles because complementary angles equal 90 degrees. Supplementary angles equal 180. So it can't be choice C. It's choice B. And this last one is also correct. And if you wanted, I would just make up numbers. I would just say like cos 10 equals sine 80. So now we know 10 and 80. Well, is it true that 10 and 80 are complementary? Yes.
Yes.
Is it true that 10 and 80 equals 90? Yes. Is it true that 80 equals 90 minus 10? Yes.
Oh, yeah.
Here, 10 plus 80 doesn't equal 180, so we could cross that out. And 10 minus 80 doesn't equal 90. That's why we could cross that out. Number 15. Find the measure of both acute angles in the diagram. All of these deal with inverse. Remember, anytime we see angle, we think inverse. So I'm going to pick this angle first. If I pick this angle, this means here's my right angle. This is my hypotenuse, but I don't need it. Here's my opposite. Here's my adjacent. Opposite adjacent is tan. So I'm going to do tan inverse of my theta that I don't know. Oops, I wrote that wrong. We know that theta equals the tan inverse of opposite, 14, divided by adjacent, 7. So all I do in my calculator is I type in second tan to get the inverse, 14 divided by 7. So I know that my theta is going to equal, doesn't say what, we'll just do 63.4. If that's 63.4, then what we're going to do is to find this angle. Well, we know there's 180 degrees in a triangle. Minus the 90 mean there's 90 degrees left for these two angles. 90 minus 63.4. And I know my other angle has to be 26.6. Down here it says cos theta equals this number. This is probably one of the easiest ones. All we know is that theta is going to equal the cos inverse of this. So all we do is type it in. So we've got cos 0.8824. So I got 28.1. A 10-foot ladder is leaning against a house. Remember, anytime that we see ladder, ramp, diagonal, that's always the hypotenuse. It's leaning against a house. with a window that's 8 feet off the ground. It's a 10-foot ladder. Nothing. Okay. So then what we're going to do is says, what's the angle from the ladder forms with the ground? So here's my ladder. It forms with the ground this angle. So that's my theta. When I label it, here's my right angle. So this is my hypotenuse. Hypotenuse angle adjacent, which we don't need. Here's my opposite. So I'm going to use sine. Sine, my theta is going to equal sine inverse of opposite over hypotenuse. So I got second sine. Oops. Opposite was 8. Hypotenuse is 10. So we're left with 53 degrees. Down here, it wants us to use these to find the right triangle. Solve for x. Here's my x. Here's my theta. So here's my right angle. So this is my hypotenuse, which I don't need. My opposite and my adjacent. So we know we're using tan. Opposite over adjacent. Remember, if my x is on the top, I multiply. If it's x is on the bottom, I switch divide. So it's on the bottom, so I have to switch it. This switches with this. And then I just divide. 11 divided by tan 40. I'm not using inverse because I'm not finding the angle. So you get x is 13.1. If you ever get something different than me, tell me, because I'm Russian. All right, flagpole casts a shadow. Shadows always are on the ground of 19 feet long. Here's my flagpole. The angle of elevation from the shadow to the top is 35. Remember, for elevation, it always goes up. If we're talking about depression, it starts at the top and it goes down. So we're trying to find the flagpole. So here we've got our opposite adjacent. Tan 35, x over 19. I'm going to multiply. Remember, the trick is put the number in first. I got 13.3 feet. Next, you decide to measure the height of the stadium lights on the Comets football field. The angle of elevation from the ground where you are standing is 32. Elevation, again, is looking up. You're 15 meters away. How tall is the light post? Again, opposite adjacent. Tan 32, x over 15. 15, tan 32. Remember, the reason why we put the number in first is so we don't have to worry about parentheses. 9.4 meters. Flip page. Okay, I'm only going to do maybe one of these. Here we have, first let's find x, which is AB. So for finding x, here's our theta. This is our opposite. This is our adjacent. This is our hypotenuse. So here I'm going to do tan 35 equals my opposite, which is x, over my adjacent, which is 11, which means we multiply. So this should be 7.7. Here we're trying to find our hypotenuse. So we're going to use cos. Cos 35 equals adjacent over hypotenuse. So we're going to flip and divide, or switch and divide. I got 13.4. And then the easiest way to find the angle, you could do inverse, but why do extra work? Just do 90 minus 35. And you could do 180 minus 90 minus 35, but it's just way easier just to subtract. Next one, let's find angle T first. Angle T will be our theta. Okay, so that's actually this one. We are given, if this is our theta, this is our adjacent, hypotenuse, and opposite. So we're going to do theta equals cos inverse, adjacent 27, divided by our hypotenuse. So we've got second cos, 27 divided by 32. I got 32.46, so 32.5. Don't do it again for here. Why do extra work? 90 minus 32.5, 57.5. And here, I'm just going to do a squared plus b squared equals c squared. So we've got 32 squared minus 27 squared. And then you take the square root. So I got 17.2. Okay. You could also have just used one of these angle measures and done it.
Is it okay if we round it?
Yep. Here it says JM. Again, I would just do our Pythagorean theorem. 11 squared plus 8 squared gives you 185. The square root of 185. Oops. The square root of 185 is 13.6. If we find m first, we're going to do tan inverse of opposite 11 divided by adjacent. Tan inverse. So we get, let's say, 54 degrees for m, which means this has to be 36 degrees for j. Moving on. I'm going fast. We get this last one in. Here we have this. We know that B is 40 degrees, DC is 16, BC is 12. So if we find this first, we'll use sine. Sine of 40 degrees equals opposite x over hypotenuse, 12 sine 40. How are we doing for time?
10:26. We're doing 10:26.
Okay, 7.7. Okay, if I do it to find this one, I've got cos 40. Oops. 12 times cos 40, I got 9.2. If this is 7.7, this is 9.2. Oh, no, this is 16. Don't listen to me. Shh. So to find the area of the rectangle, I'm just going to do 16 times 7.2. Okay. Shh. Whoops. 16 times 7. 7.7. So this is 123.2. Is that what you guys got? Hello. Area of a triangle, 1/2 base times height. 35.42. .2, 158.6. Is that what you guys got? Anyone? Yes, no? Okay, last one. Here's this. This is 20 degrees or 20 centimeters. This has to be 10 centimeters for this bottom one. Okay, so what we just do, I would just do Pythagorean theorem. 20 squared minus 10 squared gives you 300. The square root of 300 is 17.3. And then you can do area. 17.3 times 10 divided by 2 means this is 86.5. If this triangle is 86.5, this triangle has to be 86.5. So when you add it up, you should get 173. All right, you guys rock-a-doodle-doo.
I had some questions.
Yep.